All right, here we go. So this is what I just said. All right, I just talked about this. That instead of doing f and g, if we know that they're inverses, then we can actually use inverse notation. So f of f inverse of x is going to equal x, and f inverse of f of x is going to equal x. And so again, this was the inverse notation that I just talked about above. And there we go. Okay, good. So example 3. Suppose that f of x equals 4x cubed plus 7. Find f of f inverse of 5. Go. Try it. It is just 5! Yay! She's right. Cancel. My answer is just 5. What did I say again? You don't have to do any work. Okay. Doesn't even matter what the function is. Because to do this problem actually like out the long way would be a lot of work. You would have to plug in x for y, and you have to plug in y for x. You have to switch them around. You have to solve for the new inverse. Then you have to plug it back in. Then you have to simplify it all out. Okay, too much work. You're taking the function of the inverse or the inverse of the function. They cancel each other out every time. Okay? All right, now let's try this one. This is going to be a little more complicated here. Example 4. Solve the following equation for x, given that the domain of both f and f inverse is all reals, and that f of 1 equals negative 2. Okay, so this one's a little more tricky. First instinct when I'm solving this equation would be to do what? Subtract that 3, right? I just feel like that's kind of what we would just do. We're like, I see this 3 on the one side, I see a 4 on the other, let's kind of move them away, right? And you're exactly right. Let's move the 3 over. No, you're totally right. Go with your instinct. So now I have f inverse of x minus 1 equals 1. But remember, we could use some information over here. We know that f of 1 equals negative 2. Any thoughts here? Do you guys see any way we can move from here to here?
1 is x and negative 2 is y.
1 is x and negative 2 and y. So in my function, this is like an ordered pair. Is that what you mean? Right?
Yeah.
Okay. With my function, with my inverse, right, what's the ordered pair here? So it would be negative 2, 1. So if I switch them for my inverse, I would have negative 2, comma 1. Oh, wait, look. I have a 1 here. So what does x minus 1 have to equal?
Oh, my God.
Ding, 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 ding. Okay? So set up your equation. X minus 1 equals negative 2. And you can add it, and you get that x equals negative 1. And that's what we were supposed to do. Solve the equation for x. Okay, pause. Let that sink in. Think through that. What did we just do? Sometimes it's helpful, okay, to rewrite the information we're given in ordered pair form. This is my input, my output. This is my x. This is my y. Right? So when I write it in ordered pair form, 1, negative 2, and then I switch it for the inverse function, because over here I'm dealing with the inverse function, I switch it. Well, this is my x now, and this is my y, right? Well, they told us that, they gave us that same y, so the input has to be the same, and I can set those two equal to each other, okay? If I give you a problem like this, and if I'm putting it in your notes, it's probably because I'm going to give you a problem like this, right? If I give you a problem like this, it's always going to work out nicely. Like this same number is going to be repeated, or one of the same, right? In order for it to work. Okay, so there's got to be a nice number that something like this would work. Okay, so practice this one. Go back to it and try it again and see how it works. Okay? All right, let's keep going. Only 3 more pages to go. These are long today. Sorry, you guys. All right, I already mentioned how we would do this. We did this with the cubic a little bit ago. To find it algebraically, right, this is what you would do. You're going to interchange x and y, right? So we're switching x and y first. Solve for y, and then write it in the inverse notation. I will do the first one, and then you guys can do the second one. So the first one, switch this to y equals 3x minus 4. Step 1, interchange x and y. So I rewrite it as x equals 3y minus 4. Step 2, solve for y. I got the easy one here. Okay, so I have y equals x plus 4 over 3. You could rewrite that as 1/3 x plus 4/3 if you want. I don't care. And then I just rewrite it in the inverse notation. So instead of y now, I write f inverse of x equals x plus 4 over 3. And I'm done. All right, you get to try the harder one.
Right.
So rewrite it as y equals, switch x and y, and then solve for y. And I'll write it up here, so if you get stuck, you can look up here and follow along. Remember, you're solving for y. That's my answer. If you move stuff like the other way instead of the way I moved it, you might have your negatives and stuff, but if you just like multiply everything through by a negative, you should get the same answer I did. Or like divided by negative, right? So you should get something pretty close. Take a look at my steps. See if you agree with me or not. Okay. Questions? Yeah, Victor. Yeah, of course.
No, yeah.
All right, we're okay so far? So finding it algebraically, very easy, just sometimes time-consuming, but not difficult. Switching your x and y, solve for y. All right, for example 6, from example 5a, so from up here, evaluate f inverse of 2. So that means I'm going to plug in a 2 to this new equation, which was f inverse. All right, so I'm going to take that 2 and I'm going to plug it in here. So I would get 2 plus 4 over 3, which would be 6 over 3, and I'd get 2. Now it wants you to evaluate 1 over f of 2. So f of 2 is up here. Plug in a 2 up to this original equation. All right? And then you want 1 over that. So again, f of 2 is this original equation, 3x minus 4. Do you think I'm going to get the same thing? No. All right. So notice that these were not the same thing. Okay. So is an inverse function the same as taking the reciprocal of a function? No. No. Okay. So the only reason I want to point this out is because what I mentioned before about that -1, right? It does not mean flip it to the bottom and make it a positive. No, it doesn't mean it. Okay, completely wrong. It will not be true. This notation, f to the -1, just means switch your x and y's and solve it for y. Okay, that's all it means. All right, we're getting there. This next section now. We want to verify, and you're going to have to do some of this in the practice packet today.
Is this on our homework?
Yeah, it is on the homework, I think. Or was it on the homework last night? Did we do a little of this?
Yeah.
Yeah, reflecting over a line.
Yeah, that was annoying.
Was it hard or annoying? Just annoying? Okay, that's okay. I can handle annoying. Hard is what I worry more about.
I don't like annoying.
No? Okay. Well, it was, did it give you just like you had to reflect it over the x-axis and over the y-axis and over a specific line, like x equals 3 or y equals 2? Did you have to do any over like slanted lines?
Yeah.
Oh, okay, good. That's harder then. Okay, so let's talk through it here, and then you can, if you need to go back to last night's homework and redo or take a look at it again, that's fine, okay? All right, so we want to verify that those points are symmetric about this certain line that we're given. There's 2 steps here that we want to do. You want to show that the slope of the segment is perpendicular to the slope of the line the endpoints are being reflected over, okay? calculate slopes and verify that they're opposite reciprocals. That's step 1. Step 2, show that the midpoint of the segment is on the line and the endpoints that are being reflected over it. Let me just show you because this is like blah, 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 blah. So let's walk through it. It makes more sense when we do an example. So verify that these points are symmetric about the line. So let's graph them. 3, 2, and -1, 0. So here is P and here is Q. And they're supposedly symmetric over this line, -2x plus 3. Well, I can graph that line. It has a slope of -2, and it goes through, right, 1, 2. Okay. So this is the line. And so the first part is we want to show that these two, and you want to connect these two endpoints, we want to first show that these are perpendicular. That's the key. So step 1 is show perpendicular. Okay. Well, so what I have to do is just find my slope. So I'm going to find the slope of that line PQ. Okay, well, I've got my 2 points, so I just do y2 minus y1 over x2 minus x1. And so I get 1/4, or 1/2, sorry, right? And we already know that the slope of the other line is just -2. And so since we've shown that these two slopes are opposite reciprocals, we are done with step 1. So that's it, okay?
It's like a line.
Does what make a line?
Like, why should you just make a line that's the opposite reciprocal?
I said that these two.
No, like not on the right side of it.
It's a check mark.
Um,
It was my check. I was checking that they're opposite reciprocals. Okay, step 2. Show that the midpoint of this segment does indeed lie on that line. Okay? So here's step 2. So let's find the midpoint. And so the midpoint would just be 3 minus 1 over 2 and 2 plus 0 over 2. So my midpoint is 1, 1. And now I have to show that it works, that point 1, 1 does indeed lie on this line, y equals -2x plus 3. So when I take that line, I just plug in 1 and 1 for x and y. Right? Plugging it in for x and y, and just show that this does work out. Check. And so then I say yes, it's the midpoint. Something about it, the midpoint being on the line. And that's it. Once you've shown it's the midpoint so that the distance is the same, right, from either one, and that the slopes are opposite reciprocals and it's indeed perpendicular, then you are good. That's all you have to do for that process. Okay? All right, think about that for a sec. Finish copying while I stop my video.